The water cycle, nature's perfect outlet recycling system. There is a force so quiet, yet so relentless, that it has been recycling every single drop of water on Earth for over 4 billion years, long before the first humans appeared, and it will continue long after our cities have crumbled into dust. Every second, billions of cubic billions of liters of water rise invisibly from oceans, lakes, rivers, and even the leaves of plants travel vast distances across continents on invisible wings. For as life-giving rain or snow carve majestic rivers through mountains, soak deep into the soil, and eventually return to the sea, only to evaporate once more and begin the entire journey all over again in a perfect, never-ending loop. It is the same water you drank that morning with your breakfast coffee in Chicago, the same water that swells the Mississippi River during spring floods, turning vast fertile floodplains into seas of corn and soybean fields across the Midwest. The same water that once quenched the thirst of dinosaurs roaming ancient lands, fueled the classes of pioneers along the Colorado River, and will one day now reach your children and grandchildren in a future we can only imagine. This is not just the rain cycle you learned about in school. This is nature's perfect outlet recycling system. The water cycle, also known as the hydrologic cycle, according to NASA and the U.S. Geological Survey, the cycle moves approximately 495,000 cubic kilometers of water through the atmosphere every single year, enough to cover the entire planet in a layer of water nearly 2.5 centimeters deep if it all fell at once. And that the total amount of water on Earth remains almost exactly the same as it was billions of years ago. Without this cycle, there would be no life as we know it, no lush green cornfields stretching endlessly across the Midwest farmlands, no towering forests in the Rocky Mountains, no oceans teeming with fish and coral, no cool, refreshing glass of water on your table after a hot day. No snow-capped peaks feeding our rivers. Earth will be a barren, dry rock like Mars, cold, lifeless, and silent. This is the story of water's incredible journey, a journey that connects every living thing on Earth, from the tiniest microbe in the soil to the largest whale in the ocean, and keeps our beautiful blue planet alive and thriving. Join me as we follow a single drop of water on its epic voyage, from the invisible vapor in the air, through the clouds down to the ground, across the land and back to the sea, revealing how the perfect system powers everything we know and love. With real-world examples you can see right outside your window across North America today. Have you ever stood by the sea in California or Florida on a scorching hot afternoon and felt the air heavy with moisture on your skin? Or what steam gently rising from a pot of boiling water in your own kitchen and wondered whether all that vapor actually go once it disappears into the air. That simple everyday observation is exactly where the water cycle begins, powered entirely by the energy of our sun, according to NASA and NOAA. The sun's radiant heat warms the surface of the world, the oceans, lakes, rivers, soil, and even snow and ice. The energy gives water molecules enough kinetic energy to break free from the liquid state and transform into invisible water vapor that rises into the atmosphere. The process is called evaporation. The oceans only supply about 86 to 90% of all the moisture that enters our atmosphere each year. Trillions of liters every day, quietly and continually. But there is another quite often overlooked contributor that you can witness every day right in your backyard, your garden, or the vast cornfields of the Midwest. Transpiration. Plants absorb water through their roots from the soil, draw it up through their stems, and release it as vapor through tiny pores called stomata on the underside of their leaves. That is nature's way of cooling the plant while moving nutrients. When you combine evaporation from open water surfaces with transpiration from vegetation, the total process is known as evapotranspiration, the invisible engine that lifts water skyward on a global scale. In fact, transpiration alone accounts for nearly 10% of all atmospheric moisture worldwide. Picture that in vivid detail. Imagine a single drop of water from the Atlantic Ocean. One moment it is part of the vast Atlas Sea. The next, the sun's intense heat gives it just enough energy to escape the surface tension and rise at an invisible molecule of vapor. That same drop may have once fallen as spring rain on the Mississippi River basin, soaked deep into the rich soil to feed a young corn plant in a field near lower. Travel up through the plant's vascular system and then being released again through the leaves back into the air. According to USGS data, a single large corn plant can transpire hundreds of liters of water per growing season, while vast forests along the Pacific Northwest coast act like giant natural pumps, returning thousands of liters of moisture to the sky every day, and helping regulate local rainfall patterns in North America's temperate climate. Evapotranspiration is especially active during the summer months when the sun beats down relentlessly on flooded fields and lush forests. This state is the first true miracle of the water cycle. Water never truly disappears or gets used up. It simply changes form, gets energy from the sun, and prepares for its next great adventure in the sky. As that water vapor rises higher and higher into the cooler layers of the atmosphere, something truly magical begins to unfold. Have you ever looked up at the fluffy white clouds drifting lazily over Chicago on a humid summer day and asked yourself, how on earth does something completely invisible like water vapor suddenly turn into clouds you can actually see and point at, or driven through the Great Plains in summer and noticed towering thunderheads building on the horizon, wondering what exact combination of temperature and moisture caused them to form so quickly? The answer is condensation. When the rising vapor cools to a certain temperature, known as the dew point, it changes back from gas into tiny liquid droplets or ice crystals. The microscopic droplets need something to cling to, so they cluster around even tinier particles floating in the air, dust, smoke, pollen, or sea salt carried up from the Gulf of Mexico or the Atlantic. They are called condensation nuclei. Together, millions of them form the clouds we see drifting overhead. The cause is simple physics. Warm, moist air from the Gulf rises and meets cooler air from the north or from higher altitudes, causing the vapor to condense rapidly. The result, clouds that can travel thousands of kilometers before releasing their cargo. NASA explains that clouds are essentially floating reservoirs of water, some holding millions of tons of moisture at any given moment. Some clouds travel some cloud travel some cloud travel thousands of kilometers carried by powerful jet streams and weather systems before releasing that cargo. In North America, that process is dramatically visible during summer thunderstorms of hurricane season. Warm, moist air from the Gulf of Mexico collides with cooler air from Canada, creating towering cumulonimbus clouds that bring the heavy, life-giving rains the continent depends on. A single average-sized cloud may contain enough water to fill dozens of Olympic swimming pools. That each individual droplet is so tiny that it would take about a million of them just to form one single raindrop. These white clouds can float so effortlessly until they grow heavy enough for gravity to pull them down. Different types of clouds tell different stories. Wispy cigarette clouds high in the sky often signal an approaching cold front over the Rocky Mountains, while low, dark, straight clouds might bring steady drizzle to the Great Lakes region, and massive thunderheads can unleash torrential downpours that flood streets in the Midwest in minutes. The cause of the dramatic cloud formations is the clash of air masses with different temperatures and moisture levels. The result is everything from dense summer showers that nourish Midwest crops to violent storms that can cause flash flooding and billions of dollars in damage. This stage is the crucial bridge between the invisible and the visible. Without condensation, there would be no clouds to shade us from the sun, no rain to quench the thirsty land, and ultimately no fresh water for rivers, lakes, and all the billions of people and creatures that rely on it. It is here in the sky that the water cycle prepares its greatest gift to life on earth, turning invisible vapor into the visible promise of rain that certains farms from lower to desert and forests, from the Appalachians to the Pacific Northwest. Now comes the part we all experience directly and sometimes even fear: precipitation, the moment water returns to the ground. Have you ever been caught in a sudden, heavy downpour while driving through the bustling streets of New York or Chicago? Rain hammering loudly on your windshield, and wondered where exactly did these specific drops start their long journey before they landed on me, or what news reports record rainfall in the Midwest and asked why some years bring gentle rains while others bring devastating floods. When the tiny cloud droplets collide and grow heavy enough, through a process coalescence or the background process in cold clouds. Gravity takes over, they fall as rain, snow, sleet, hail, or even freezing rain. USGS and NOAA data confirm that on a global scale, the amount of water returning to Earth's surface through precipitation roughly equals the amount removed by evaporation, keeping the entire cycle in perfect long-term balance. The cost either continues build up of moisture in clouds until droplets become too heavy to stay suspended. The result is the life-giving water that replenishes rivers, lakes, and aquifers while also sculpting landscapes over time. In North America, this stage is most dramatic and vital during spring and summer rains or hurricane season. Heavy rains can swell the Mississippi River to overflowing, flooding the basin and depositing nutrient-rich sediment that has threatened American agriculture for centuries. Annual rainfall varies sharply across the Mississippi River Basin. Coastal Louisiana receives about 1,600 millimeters per year, while inland areas in the Midwest get around 900 to 1,200 millimeter. Wet, warm, moist air from the Gulf delivering the bulk during the growing season. A single strong rainy season can deliver enough water to irrigate millions of hectares of corn and soybean fields, the very backbone of the nation's food security and economy. But precipitation is not always gentle. Intense storms can trigger floods in the Appalachian Mountains or devastating landslides in the Pacific Northwest, as seen in recent years when heavy rains overwhelmed drainage systems in urban areas. The cause of the extreme events is often the collision of warm, moist Gulf air with cold fronts or the remnants of tropical storms. The result is both beneficial soil moisture for crops and destructive flooding that can cause balancing damage and disrupt supply chains across the country. That even in moments of destruction, water is simply doing its job, sculpting the landscape, carving valleys, and replenishing underground aquifers for future use. Every single drop that hits your rooftop, plashes on your skin, or soaks into the soil carries with it a story that may have begun weeks earlier in the warm waters of the Gulf of Mexico of the Atlantic Ocean. Some of that water might have circled the globe multiple times before finally choosing your cities as its landing spot. There is precipitation in action, the visible, dramatic return leg of the cycle that brings freshness and renewal to our world while also reminding us of nature's power to pour nurture and reshape the land we call home. Once the water reaches the ground after precipitation, its journey does not end. It branches into multiple precise paths and that shape landscapes, certain economies, and support daily life across North America. This is where the cycle becomes deeply personal and tangible. With concrete examples you can see along the Mississippi every season. Some of the water flows rapidly across the surface as runoff, gathering into small streams that merge into mighty rivers and ultimately return to the ocean. In North America, the most iconic example is the Mississippi River, one of the longest and most productive waterways on the continent. According to the U.S. Geological Survey, the river has a total annual runoff of approximately 475 cubic kilometers across the entire basin. During the peak flood seasons, March to June, their floodplains can raise water levels by 4 to 6 meters in the lower basin, depositing millions of tons of nutrient-rich sediment that fertilize the soil for corn, soybean fields, and aquaculture. That runoff not only irrigates millions of hectares of farmland, but also supports fisheries that provide a major portion of the animal protein for people in the lower Mississippi basin. Have you ever crossed Mississippi by bridge in St. Louis and noticed the powerful currents swirling below and watched fishermen cast nets during the flood pools? That is runoff in action. Water that may have fallen as rain in the Rocky Mountains months earlier now carving channels, preventing saltwater intrusion in wet season, and powering port traffic that connects millions of lives. The cost of strong runoff is heavy rainfall on saturated or sloped ground. The result is both fertile soil deposition that boosts agriculture and occasional destructive flooding that requires lives and emergency planning. Not all water rushes away so quickly. A significant portion slowly infiltrates the soil through pores, cracks, and root channels in a process that acts like NATO's underground storage system. In the Mississippi River Basin, the infiltration recharges vast multi-layer aquifer systems. The Ogallala aquifer and others that hold enormous volumes of fresh groundwater. USGS studies show that shallow aquifers are directly connected to surface water, allowing rapid recharge during floods, while deeper layers filter water more slowly and store it for decades or centuries. Farmers in the Midwest rely on this groundwater for about 40% of agricultural needs and a large share of domestic supply, pumping from millions of wells. That infiltration is under pressure. Excessive extraction causes groundwater levels to decline in many areas. A land subsidence occurs in hotspots like parts of the Central Valley in California. Have you ever noticed how wells in the Great Plains sometimes run lower during prolonged dry spells, or how roads crack and sink in certain agricultural regions? That is the visible consequence when infiltration cannot keep pace with demand. The cause is overpumping combined with reduced recharge from changing rainfall patterns. The result is sinking land, higher pumping costs, and long-term threats to the food production that feeds much of the nation. Water that neither runs off immediately nor infiltrates gently may linger as soil moisture, feeding plant roots and maintaining wetland ecosystem like the Everglades in Florida or the flooded forests along the Mississippi. The pathways make the landscape incredibly resilient. During North America's dry seasons, stored groundwater and slow runoff keep rivers flowing and crops alive even when rain is scarce. Without the detailed journey on land, the Mississippi River Basin, home to millions of people and producing over half of America's corn and soybeans, would turn into great earth-getting waste. Every part runoff, infiltration, soil moisture ensures that water keeps moving, featuring and sustaining life in a perfectly balanced, never-ending loop. Here is perhaps the most beautiful and profound truth of entire cycle. The water cycle does not merely move water around the planet. It actively sustains every single living creature and ecosystem on Earth in ways that touch our daily lives more intimately than we realize. Have you ever watched a young child joyfully splashing in a fresh puddle after a rainstorm in Central Park and realize that without the water cycle working perfectly every single day, that simple moment of happiness could never exist? Plants depend on water for photosynthesis, the miraculous process that turns sunlight, carbon dioxide, and water into energy and oxygen. The very air we breathe in the Midwest confirms that it visible the raw spring rains flood the fields, allowing natural ecosystem to thrive, while the nutrient-rich water supports massive harvests, producing just 1 kilogram of corn, the staple that feeds livestock and people across North America requires up to 2,500 liters of water that has cycled through evaporation, condensation, and infiltration countless times. Animals drink it to survive. The Mississippi, the fish species rely on the seasonal flood ponds for breeding and feeding crops. Humans use it for everything from cooking our daily meals to growing vegetables, brewing coffee in the Pacific Northwest, and powering industries. NASA data shows that nearly every ecosystem on the planet, from the coral reefs of Florida to the evergreen forests in the Rocky Mountains to pursuing cities, depends completely on the reliable, continuous movement of water through this cycle. Consider your own body. On average, an adult human is about 60% water. Babies start at 78%, dropping to around 65% by age 1 and stabilizing in adulthood. The blood is 83% water, muscles and kidneys 79%, even bones contain 31%. Every day, an average adult male needs about 3 liters and a female about 2.2 liters just to maintain metabolism, transport nutrients, regulate temperature, and remove waste. Water that is constantly renewed through the cycle. The oxygen you inhale right now was likely produced by phytoplankton in the oceans or trees in the Mississippi floodplain, powered by water that evaporated from the Gulf of Mexico only days ago. Even the food on your dinner plate tonight, whether grilled fish from the Gulf or fresh herbs from your backyard garden, is intimately tied to the cycle. The Mississippi River Basin alone produces over half of America's corn and soybeans. Without the precise timing of runoff and infiltration, the harvest would fail. From the tiniest plankton in the oceans that form the base of marine food chains to the massive basins drinking at water holes on the Great Plains, every living thing is connected to that shared resource. In the Everglades ecosystems, water recycling supports biodiversity that protects coastlines from erosion and provides nurseries for fish worth billions in economic value. The cost of great life is the steady supply of fresh water moving through the cycle. The result is thriving ecosystems that support tourism, fishing, and clean air and water for millions of people. Without this water cycle, Earth would be as lifeless as the dirty surface of Mars. With it, we are blessed with forests that clean our air, oceans that regulate our climate, wetlands that filter pollutants, and the fresh water that makes human civilization. And every joyful splash, every home-cooked meal, every pride possible. The water cycle is remarkably resilient and self-regulating, but it's not indestructible, and human activities combined with climate change are now putting that delicate balance under increasing measurable pressure in ways that affect millions of North American families every year. Have you ever wondered why some years the Mississippi River Basin suffers from severe drought that kills crops and forces families to buy drinking water, while other years it experiences devastating floods that submerge homes and roads for weeks? Climate change, as documented by NOAA and NASA, is already altering global and regional precipitation patterns, making wet regions wetter and dry regions drier. Rising temperatures accelerate evaporation rates by 5 to 10% in temperate areas, while shifting storm patterns and melting Rocky Mountain glaciers affect the Mississippi's flow in the Mississippi River Basin. Specifically, foggy drivers are intensifying the disruption. Upstream dams land subsidence from excessive groundwater extraction, averaging several centimeters per year in hotspots. Relative sea level rise along the Gulf Coast and riverbed changes. USGS and recent studies show that salinity institution the advance absorb water in freshwater zones. Freshwater zones had become more frequent and severe in the lower basin. In recent major drought events, water traveled farther upstream, affecting multiple states, destroying crops across hundreds of thousands of hectares and causing billions in agricultural damages. Projections for 2050 and indicate further advances under moderate sea level rise scenarios, with effective sea level rise, including subsidence, being the dominant factor during recent dry seasons. Intrusion forced emergency water supplies and crop ships in Louisiana and other Gulf states. The cause is a combination of warmer temperatures, increasing evaporation, altered rainfall patterns, concentrating rain in fewer but more intense events, and human infrastructure reducing natural recharge. The result is alternating extremes of drought and flood that strain farms, cities, and ecosystems alike.